who's going to be talking about playing with multivariable calculus and 3D glasses. This webinar is sponsored by the American Mathematical Association of Two-Year Colleges, or AMATYC for short. You can find more information on their webpage, which is amatyc.org. Views expressed by presenters are not necessarily the views of AMATYC, and if they talk about commercial products, they're not endorsed by AMATYC. The web platform that we're using is provided by Muskegon Community College's LIFT Institute, and if you have suggestions about future programs or ideas for future webinars, please contact me, and you can see my email address there at the bottom. And now I'm going to switch over to the other slides, so I'll give you a second here. Minimize this and go to my other little pod. One. Recently shared, that's what I'm looking for. Hopefully this is the right one. Okay, so I'm going to stop my webcam and let you go, Paul.
Okay. All right, hopefully everyone can hear me. Please do let me know if you cannot.
Haha.
I guess you wouldn't know if you didn't hear me. Haha. So I want to welcome you to this webinar. We're going to talk about playing with multivariable calculus with 3D glasses. And I'm wondering, first of all, how many of you actually have 3D glasses with you at this point? If you do, we might make a little bit more use of them during the webinar than if you don't. Indicate whether or not you have some with you.
Paul, your sound just got really strange all of a sudden. Okay,
was that better?
Yeah, that's better.
Okay, I moved my headphones a little bit. Okay, so we have no for the majority at the moment.
Well, you have to remember that one of those is a room full of students who has all 3D glasses, so it's a little bit higher than you think.
We have a huge number of people that do. Okay. Thank you. All right, let's go with the next question, which is, how often do you teach multivariable calculus on average? Got some choices to select from. You have to resize it to see all of them.
There you go.
Okay, looks like it's settled. We have quite a nice breakdown here. Why don't we try the next one, which is basically what technology do you currently use in your multivariable calculus course, those of you who teach it, to help students visualize the concepts and select all that apply. I lost sight of the
yeah. You got to be a little careful, Paul, because you're in here as a host, so you can actually do things that you normally couldn't. Yeah, 1 second.
Sorry about that. I didn't know.
Yeah, normally you don't have that power, but you do today. Be careful with that power.
All right, I didn't see the one that I was looking for, which was CalcPlot 3D itself. I had included that as one of the options.
Oh, I'm sorry. I must have missed that.
So I can't ask them that very well, but I guess I could ask it in the text window. If you use CalcPlot 3D, you could enter use it or use CalcPlot 3D on the text window already. So if you already have used it some. Okay, we probably should keep moving then. So I've got some answers coming in. Number 5, is that what's up there now?
Yep.
Do that now. Okay, so if you've used visualization in the past, how have you used it in your classes? All that apply. So a number of ways we can do this. I think the majority of people often would be to do things in lecture and talk about. It's very useful if we can get our students on there using visualization features as well. So we've got, great. Settle down. Excellent. Well, let's get started here. I see time is ticking away, so I'd like to get ourselves to the presentation. So I'm going to move to the next slide. And
it should be in the bottom left.
Oh, I see it. Okay, sorry. All right, so the main goal of my project is to improve student understanding of the geometric nature of multivariable calculus concepts. Basically to help them develop a geometric intuition about these concepts and the relationships between them. The project that I'm working on, it's a National Science Foundation project that I'm in the 4th year of a 3-year grant. I've actually added 1 year extra already. And I've created the applet, which is a visualization environment for multivariable calculus. I've created a few sort of special starting points that are focused on a particular topic that use this applet. Developed some guided exploration assessments already, and we're now most of this. I think I'm going to wait on this actually because I think this timer I want to show you the applet.
Can you check your mic again?
Is it off or?
It's like it's almost like your voice gets muffled for a little while and then it comes back.
Okay, my mic probably needs to be improved. Is that louder?
It's fine when you must be like looking down and then looking up or something because it goes quiet and then when I say something it's perfect again. So.
Am I too loud now?
Yes.
Is this better?
Yeah, that's fine. I'll just warn you if you get muffled.
Please do. All right, I'm going to go ahead and start sharing my screen. To do that.
Oh, here, let me.
Pods.
Go to share and then there's on the upper right hand corner of the box, the drop down menu where it says share and then go to my screen.
Upper right hand corner of the box.
Of the slide box.
All right, stop sharing and
then below that it says share my screen. So choose share from that menu and then my screen.
Got it. I found the little drop down. Sorry.
That's okay.
Okay, so desktop, share that, and now you can see the, well, eventually here you'll be able to see the
there it is, I can see
Exploring Multivariable Calculus window. I'm going to go to the applet, which you can either link on here or I've got it open already, so I'm going to go straight to it. So now the applet itself has a number of features that I'm going to try to give an exploration of, and I want to also share some of the new features that some of you who've used the applet before may not have seen. So to begin with, you can graph a function of two variables.
You're getting soft again.
Entering it in this function box, function 1, 2, 3, or 4. Is that better?
Yeah, it's almost just like you're looking away from the mic, and when you start talking that way, it goes away. Okay.
So I could enter x squared plus y squared, for example, and press enter or the graph button, and it will show the graph of the paraboloid, x squared plus y squared. You can grab the solid or the surface and rotate it and get a different view. It's a little bit good when you're seeing it on the webinar here, but when you try it yourself, we can also do a number of things with this surface. And we could do is plots.
You're getting muffled again.
We choose the contour plot option. Draw contour plot from that contour plot menu. Choose the function we want contours for, and if you want function 1, select it.
Muffled again. Can you maybe just move your mic to like your other lapel or something? Is it something like that that can be just changed?
It's a headphone mic.
Oh. Any way to move it to the other side?
Is it any better? Let me bend it a little bit. Sorry. Is it better or worse?
That's great right there. If you can keep it right there somehow. I'm not sure what's happening that it's getting muffled, but my guess is you're somehow looking away or something. I'm not sure.
Okay. So, sorry, I was distracted here. I'm going to go back again real quick. So I entered the first level, 0, for the x squared plus y squared, entering 0.2 for a step, and 11 contours. You can enter whatever you want for a step size. The assumption is that these will be equally spaced in the z direction. It will show the values down below, although you have to exit one of the boxes if you change something. You can enter a list if you want them to be not equally spaced. Clicking OK will show contour plot.
Oh, your sound's faded again. Tell you what, I don't normally have my mic on. I'm going to turn my mic off, but that means I can't tell you if there's a sound issue. But that's the only thing I can think of that's different from the last webinar.
Okay.
So let me turn off my mic and see if that helps at all.
All right. I have a new computer. That's the other difference. But
oh.
Anyways, can people still hear me? If not, I guess they're not going to know, but hopefully. All right. So I say yes. Good.
All right, so once you're on this window, many times in the applet, there's a message that gets sent to your phone for the plot. It says click on it. Shows the contour plot.
So I had to unmute my mic again because I think I figured it out, Paul.
Yeah.
It's as soon as you start to move your mouse on the screen, we lose your voice. So it might be best if you and it might be a bandwidth issue at where you're broadcasting from. Are you broadcasting from school?
From work, yeah. And it may be just time of
Okay.
day, I don't know, but you might be right.
So it might be best if you pause on the screen, tell us what you're going to do, and then do it without talking, and then tell us the next step. It's because as long as your mic and your mouse are not moving at the same time, we'll be okay.
Okay, we will try this again. That's very difficult, by the way.
I know, but every time you start to tell, it's like it fades as you're talking until it's nothing. And then as soon as you stop moving your mouse because I distract you, you're right back to normal. So.
Okay, well, tell me if I'm doing better. So right now we can see the 3D plot of the contour plot that's projected up onto the surface, and you can sort of tell that the z-values are equally spaced. Didn't move my mouse.
As soon as you start talking about the presentation, your voice gets muffled. Are you looking down at a tablet or something?
No. Is this any better? I've got the mic.
That's fine right there.
I got the mic like in my mouth.
Something must change when you, swallow the mic, would you?
Okay, I'm trying. You'll hear my breath now.
Oh, that's a good question. Joel has a good point. He says, "Is your hand covering the microphone on the computer? Do you think you're using your headset and you're actually using the mic on the computer? And when you go to start typing or moving your hand, it's covering the mic on the computer?"
No, I don't think so. The mic that I'm using is on my mouth right now. Is this any better? Are you hearing me now? It's still muffled.
It's muffled like that.
Okay.
Yeah.
I have no idea. Maybe my.
And that's fine right there.
This is fine right here. You guys.
Yep.
This is not what I wanted to do, but okay, let's keep talking. Hopefully you'll hear some of it.
And now it's gone.
Oh my.
And now it's back.
Well, it may just mean I need a new mic. Maybe if I go to my laptop, I could just use the mic on it.
Yeah, let me change you over to presenting on your laptop, but you got to make sure to turn off the presentation in your
Yeah, I see.
Turn off the mic in your main presentation, and I will go turn on your laptop.
Okay.
We have a backup plan, you see. I can make you a presenter. There we go. Right now, Paul's laptop is a presenter. Try it from there. Give us a second here. We're going to see if we can fix this. Exactly. Thanks, Joel. Great attitude. We're mathematicians. We will conquer this. I'm not hearing you yet, Paul.
Can you hear me now? Loud and clear? All right, why didn't I use my laptop to begin with? All right, let's get going. You didn't? Okay, someone said loud and clear and yes and yes. Okay, I'm going to try sharing my screen here. Yeah, why didn't I use my laptop, right? All right. All right. All right, so let's see, share my screen. Tried to do that already once. Let's see. Oh, you're seeing range. Okay, so you're seeing now? Okay. All right. Get into Windows and show you this. Oh. Hello. All right. Figured. Should have thought of that sooner. Okay, open my applet. It'll be off, hopefully. Okay, well, as we get back into this, maybe we could do one of the other questions as I'm getting this started. Which topics that you teach do you find most difficult for students to visualize? Number 6. Select all that apply. Okay, nice smattering of all of those. Intersection of surfaces and vector valued functions, parametric surfaces look to be coming out on top. My applet is just about loaded. Apparently it's taking a little while too. Okay. My applet is up. And 7, you know what? Do 7 as I resize the window. Do 7, question number 7, as I resize the window. See that that's not quite right. So still doing interesting things as it resizes here. Is it? Okay, it's supposed to be the whole screen, but it seems like stretching it out. Oh, now it's doing something interesting. I don't know what's going on there. Okay, it's finally getting itself settled in, I hope. All right, I think I'm back, although it seems not to quite have sized it right. But let's go ahead to the next, to my window. So take that one off. All right. So we are looking at the applet again, and now we're ready to do something more with it, I hope. So we have the 3D glasses. Let's turn the 3D glasses mode on. We can use the little 3D glasses icon right here, the button, and we'll turn it on. And those with 3D glasses can test them out on the screen that you're watching. It'll be best when you actually use the applet on a computer, but it still does show up here on the webinar. Okay, looks like. And got a little too close in, but sometimes coming in we can get a better view. If you use the scroll wheel on your mouse, it'll bring you in. You can also do scroll wheel in and out, up and down will bring you in and out as you want to zoom it, like happens in a lot of photo applications. So how does that look? Does it look 3D? Not getting much response yet, but okay. I'm going to show you some other things that look good in 3D while we're at it. So I'm going to clear the window with this little clear window button, clear graphs button. And we're going to go to graph, and parametric surfaces come out really nicely here. Some of them do. So I'm going to add a parametric surface and come up to the example list. You can enter anything you want in terms of X, Y, and Z using the parameters U and V here. And the big nod is a very nice one for this option. It actually would have been better if I'd chosen the quick plot mode, but it's coming. All right, so this one, if I move it over, by the way, right-clicking and dragging will move that view around, and it's useful if you're presenting as a teacher sometimes. And now we can bring it in a little closer. Rotate a little bit. Okay, how does that look with the 3D glasses? This is a good one to test them out. I don't see many comments, but you're welcome to comment there. I'm looking for them. All right, so other parametric surfaces that you can graph, that was one of the topics that was listed as difficult. It's not always taught, I know, but it's certainly a pretty one to explore. The Möbius strip is one that's sort of nice to see, and it's a nice, easy one to demonstrate. You can use the show trace point here to demonstrate where the point is on the surface, depending on the U and the V. So how that parametric surface is formed. If you move that point along the surface using the scroll bar, you can see that changing the U value moves it along the Möbius strip, and changing the value of V moves it left and right across the strip. It's sort of helpful